All right, seeing that it's noon, let's go ahead and get started. Thank you everyone for sharing your lunch hour with us. Welcome to the second of 4 webinars on how to use sea level data in the classroom. My name is Abby Wakely, Socorro's Communications Director, and I will be facilitating and moderating the webinar. If you have already, please watch the first webinar, Causes of Sea Level Rise. It is available on this link here, socorro.org, Education and Outreach, and then the Sea Level Rise curriculum. And I should have emailed it to you this morning, and if you haven't gotten it, please reach out to me. All participants will be in listen-only mode. You are encouraged to type questions for the presenters or technical questions for me in the bottom right-hand chat box. I will respond to them directly or post the questions to our presenters after their presentation if there is time. We're recording this webinar today and we'll be posting the recording on the Socorro website. Webinar 2 is the introduction to the phenomenon of coastal flooding in the Savannah, Tybee area, in particular looking at Fort Pulaski historical data. We are excited to welcome back Jema Koval and Dr. Alex Robel from the Georgia Institute of Technology. Let's go ahead and get started. Jema and Alex, I'm going to promote you to presenter now. 1 second. All right. Passing privileges to you all.
Okay. Can you all see that?
Perfect. Thank you.
Great. Thanks. Okay. So I guess we started in webinar 1 with sort of a general introduction to, some of the basic concepts behind, what is sea level, what contributes to sea level, and how changes in sort of the global environment can cause sea level rise. So today we're actually going to go from the global view to sort of narrow in on an area that's near and dear to us, the Savannah, Tybee area in coastal Georgia. And we're going to talk a bit about some of the changes that have occurred in that area in coastal Georgia over the last century or so, and how those can be used as the basis for a classroom activity. So that's us. And today's agenda is I'll give a sort of an overview of kind of some of the observations that we've seen of coastal flooding in the Savannah Tybee Island area. And then Jema will do an overview of an activity, a classroom activity, focusing on the flooding of Highway 80 in the Savannah Tybee area. Okay, so just to situate us, so here's a snapshot from Google Maps where you can see a map. So on the left of the map is the Savannah metropolitan area, and then the right side of the map is basically the Atlantic Ocean off the coast of the Georgia-South Carolina border. And that barrier island that you see on the right-hand side of the map is Tybee Island, which is a barrier island community with a permanent population of just over 3,000, but the population fluctuates a lot with season. It's a very significant tourist destination in the state of Georgia. And so Highway 80 is about I think at this point, about an 80-year-old highway that extends it goes straight through the city of Savannah, and then it goes through various barrier islands and through the Fort Pulaski National Monument, which is a protected wilderness area, and then onto Tybee Island. And so you can see that Highway 80, the sort of part of it that we're interested in, outlined in red here on this map. So if we look at data from the tide gauge at Fort Pulaski, so just to kind of back up here for a second, Fort Pulaski, I should have marked it on this map, but in any case, Fort Pulaski is the site. So it's here kind of just off of Highway 80, is the site of the only long-term tide gauge in the whole state of Georgia. And so if we look at some data about water levels and particularly high tide levels from the Fort Pulaski gauge. So the Fort Pulaski gauge started in the early 20th century. And so here what I'm showing are 2 histograms in this plot from the Pulaski tide gauge. The blue line is the high tide level above a certain reference elevation. Over a 5-year period from the years 1935 to 1940, and the reason why that is significant, why that 5-year period is significant, is because that is the time during which Highway 80 was being built or extended rather, to Tybee Island. So the blue line shows basically how high the high tide is. To the right on the plot is higher high tide, and the number of times that high tide level occurs in any given year. And then the red line is the same thing, except taken over the most recent 5-year period. And what I've plotted here is a gray dashed line, which indicates how high the high tide would have to be in order to overtop the seawall that protects Highway 80 from coastal flooding. So as you can see that in the 1930s, when Highway 80 was extended to Tybee Island, the average high tide was about 3 feet below the level of the seawall protecting Highway 80. And with the slow but progressive shift upward in the high tide level due to sea level rise that has occurred over the last 80 years, this has put us into a regime where the average high tide is closer to the level of Highway 80, and then several times a year, high tides will be high enough, actually this time of year, when there are king tides, which we'll talk about in the next webinar. When you have particularly high tides, they can overtop onto Highway 80. So you can see an example of this from 2015. Here's a really nice aerial shot from a particular king tide in late October of 2015, which flooded over all of Highway 80, and this effectively cut off Tybee Island from any emergency services. So this, phenomenon of coastal flooding in this area it's sort of not new, and it's long been known that this area is particularly vulnerable to coastal flooding. So here what I'm showing is sort of a similar map. This is a sort of somewhat of a wider view, but the same area, Savannah and Tybee Island, all the way on the right of the map. And what this shows is a map, I think, made by, I don't know who makes this map, but it basically shows different flood areas for hurricanes making landfall in this region, or for a hypothetical hurricane making landfall in this region. So you can see that a large part of the sort of wildlife and natural parts of Chatham County here flood for relatively low levels of storm surge from a hurricane. And then once you get into the city of Savannah, progressively higher storm surge can affect the center of the city as well. So this area is well known to be vulnerable to coastal flooding, but the frequency of coastal flooding has progressively been changing over time. So looking at major flood events, which are defined as far as the height of the flooding goes over the last 4 decades, what you can see is that while there are significant fluctuations from year to year, in the last 10 years or so, there have been considerably more minor, moderate, and major flooding events than there had been in the previous 30 or so years. And so you've seen as the baseline level of sea level has gone up in this area by about a foot over the last century, the frequency of coastal flooding has increased as well. So here's a sort of another way of looking at that. So the result of this is, or the response to this increase in coastal flooding, and particularly the danger that is posed by the flooding in particular of Highway 80, which completely cuts off Tybee Island from the city of Savannah, which is where most emergency services for the area, for the county, are based, is that just earlier this year, the Georgia Department of Transportation spent $2 million, which of course is very little as far as highway budgets go, but just for one small stretch of one part of Highway 80, that the sort of lowest part of Highway 80 was raised by the Department of Transportation in order to prevent some of these minor floods from occurring. And so what we can see is that there's a number of dimensions that are sort of at play here in this flooding, Highway 80 flooding problem. You have long-term environmental change that is occurring. You have the built environment, which was built at a time when the environment looked very different from what it is now. And then you have a governmental response to that vulnerability presented by the environmental changes that we've seen. So that's it for my overview, and now I'm going to turn things over to Jema to give an overview of a classroom activity related to this problem.
As you've seen from the curriculum downloads, the module that we've designed follows the 5E model of instruction. And during the engage stage, the focus is on capturing student interest and activating their prior knowledge. We haven't talked about the activities in this stage, but here students are connected to the real-world problem of coastal flooding in the Savannah, Tybee Island area through videos and newspaper articles, which then set the stage for the rest of the module. The activity that we'll discuss in more depth today, the flooding of Highway 80 activity, is one part of the explore stage of the curriculum. Here students are actively exploring and investigating the phenomenon while developing a common base of experiences. We'll discuss the activities for the other stages in the next couple of webinars. So today's activity focuses on the phenomenon of coastal flooding on Highway 80. This is an original activity that is aligned with state and national science and math standards. On the science side, it supports standards about the role of water and effects of the relative positions of the sun, earth, and moon. The math standards all fall under the statistics and probability domain, as students are tasked with developing an understanding of statistical variability and summarizing and describing distributions. This activity also highlights NGSS Science and Engineering Practice number 4, Analyzing and Interpreting Data. Organizing and interpreting data is a major practice of scientists because raw data on its own has very little meaning. Through this activity, students will organize and interpret data through graphing and statistical analysis in order to bring out the meaning of the tidal data and its relevance. But before looking at any data, first students have to learn background information about the area under investigation, including that US Highway 80 is the only road connecting the Savannah metro area with Tybee Island, and it crosses marshes, rivers, and other low-lying areas. During times of coastal flooding, the highway can flood and become impassable, cutting off residents and visitors on Tybee from emergency services, creating a potentially devastating situation. The Fort Pulaski tide gauge monitors high and low tides along the Savannah River right near Highway 80, recording approximately 2 high tides and 2 low tides each day. So this gauge is used to determine flooding along the highway. As you can see on the slide, there are critical tide values for the gauge, and if the water rises to 9 feet 6 inches, then the highway would be closed. Students also learn about GDOT's planned road improvements and how they might decrease road closures. With all of that in mind, let's take a deeper dive into some of the historical Fort Pulaski tidal data. So for this activity, since we're focused on coastal flooding, we're only going to consider the high tide data from Fort Pulaski that was recorded during the 15 sample months that you see listed. If you're looking at the curriculum files for this activity, you'll notice that there are 15 files, one for each of the sample months, and each file is identical except for the data tables embedded within. I created 15 different data sets from 2015 through 2018 so that students could have unique data sets to work with. You can pair up students for this activity, or you can let them work individually. And you could also model how to work through one of the data sets for your entire class before assigning the rest of the files to your students. So when students first take a look at their files, they see the high tide data from Fort Pulaski for a given month, which includes the dates, times, and water levels recorded. But at this point, the raw data in these tables has little meaning. The students have to first organize so that they can interpret the data through graphing and statistical analysis. Through this analysis, students can make better sense of the data and use evidence to inform an audience about coastal flooding. A quick reminder that the curriculum was written to target 6th grade students here in Georgia, because that is when earth science is taught, and the math that is integrated in this activity would be taught that same year. In your classrooms, if students haven't learned these concepts or say that they've forgotten them, the curriculum was written to guide students through that analysis step by step to help them be more successful. For this example, so students will use the data set that they are given to explore multiple ways of displaying and visualizing the data. First, they take the tidal data that you saw on the initial slide from the entire month, and they order the values from least to greatest. Organizing the data in this step will then make it easier for students to graph and complete the statistical analysis later in the activity. They then take this data and plot it on a histogram, which is a type of graph that shows the frequency that a specific outcome occurred. As you can see in this example, they use an X to mark the occurrence of each tidal range, and for values of 9.2 feet or higher, they're going to use a different color pen or pencil to mark the X, as those values are going to signify a coastal flooding event. Completing just these first two activities, students can already see that the raw data has more meaning now, and the histogram communicates more easily which high tide values were more frequent for the month, while the use of color is going to communicate coastal flooding events in a much easier to spot fashion. Next, students are going to apply some of the statistics content that they've learned in their math classes. They're going to use measures of center, mean, median, and mode to describe the data set, and they are going to use measures of variability, range, lower and upper quartile, and interquartile range to better understand how much the data actually varies by. The instructions for completing these calculations are included in the activity, as you can see in the slide, to guide students and teachers along in case they don't remember the steps. Having students apply this math content in their science class while analyzing an authentic data set is one way that we try to address the why are we doing math in science class conversation. And it also shows students just how integrated math and science really are. So from their calculations, students can then communicate more information about the high tide data for their month, including what the average high tide was. And in this example, they can also communicate that 50% of the high tides for the month fell between the range of 7.1 and 8.1 feet. Finally, students have some questions to reflect on based on their data set analysis. There are questions that focus students on the high tides that occurred at Fort Pulaski and the coastal flooding events, and they have the opportunity to compare their results to another group's, as well as return back to the topic of the planned road improvements for Highway 80 and explore if there would have been road closures that month, even with the planned road improvements. Comparing their results with those of another group might lead students to additional questions about the tides in general, such as wondering if there are seasonal differences at this tidal spot. This slide will share where you can access additional data if you'd like to expand on this activity, or if you would like to collect data for a different coastal location. I also want to point out the two questions that are highlighted in red, and that's because at this point in the curriculum, students have not necessarily learned any foundational science about the tides. Questions 2 and 3 are designed to lay the groundwork for further exploration of tides which they'll learn in the next activity. Depending on the length of a class period, this activity would probably be completed in 1 to 2 classes, depending on how you would like students to do the analysis. So this is the site where we collected all of the title data for the activity. And if you'd like to access additional data for gauges around the US, tidesandcurrents.noaa.gov will be a great source for that information. Thank you. So our next webinar next week, we're going to talk more about the Smart Sea Level Sensor Project. We're going to go into more depth about the tides and the data analysis activity, focusing on the Fort Pulaski tides.
Thanks, everyone.
Great. Thanks so much, Alex and Jema. So we do have some time for questions. If anybody has any questions, you can type them in the chat box. And I will ask Jema and Alex. All right, I am not seeing any questions right now. So what we can do, if you guys do have a question, you can email them to communications@socorro.org, and we will send them to Alex and Jema. And then as a reminder, please register for the 3rd webinar on October 22nd at noon. As Jema said, it's the Sea Level Sensor Project plus available data from the sensors. And this recording will be available in 24 hours on the website. Thank you guys so much for joining us. Have a great day.